Good afternoon to one and all. I am R.V. Kiran, Assistant Professor, Department of Mechanical Engineering. Today in this video lecture, I am going to explain you the last model in the first three types of motions, that is the mixed motion of follower. So in the previous class, I have described about the two types of motion, that is the simple harmonic motion in the outstroke and the uniform acceleration and deceleration in the return stroke. So two types of motion in only one type of follower. In the previous problem, we have discussed about the roller follower, and today we are going to see the roller follower with simple harmonic motion and uniform acceleration. And this is my 47th lecture regarding to the subject kinematics of machinery. So this is the question. So it is required to set out the profile of a cam with the oscillating follower for the following motion. So the motion has been taken here. Follower to move outward through an angular displacement of 20 degrees. So the follower is moving the outward motion with an angular velocity of 20 degrees during the 90 degrees of cam rotation, that is first 90 degrees of cam rotation. And next, the follower to dwell for 45 degrees of cam rotation. So in the next 45 degrees, it is the dwell period. Third one, the follower to return to its original position of zero displacement in 75 degrees of the cam rotation. So the follower is set to come to its original structure with its zero displacement in 75 degrees of the cam rotation. And follower to dwell for the remaining period of the revolution of the cam. So that is to be dwell for the remaining period of revolution. Next, the distance between the pivot center and the follower roller center is 70 mm and the roller diameter is 20 mm. So the roller center is 70, it is given as 70 mm and the roller diameter is 20 mm. The minimum radius of the cam corresponding to the starting position of the follower is as given below. So the location of the pivot point is 70 mm to the left and 60 mm above the axis of rotation of the cam. And the motion of the follower, that is the motion of the follower, is to take place with simple harmonic motion during outstroke and uniform acceleration of retardation during return stroke. So they have given as the uniform acceleration and retardation during the outstroke and simple harmonic motion for the outstroke, and uniform acceleration and retardation during the return stroke. And the follower is the oscillating follower. So the huge difference between the previous problems and today's problem is they have given the oscillating follower. So generally in the university exam they will give the only three types of followers, that is the knife edge follower, roller follower and flat faced follower. But here, to be a difference in the problem, of change in the problem, to be twist in the problem, they have given the oscillating follower. Oscillating. So the oscillations have been given as 20 degrees during first 90 degrees of cam, that is outstroke. So we have to draw the profile of the cam and draw the displacement diagram here. So first of all, we need to find the angular displacement of the roller follower. So they have given us 20 degrees during the outstroke angle 90 degrees. So they have given us, we know the angular displacement of the roller follower as 20 degrees. That is 20 into pi by 180. So we are taking it as the half of the revolution. That is 180. In total, it is pi by 9 radians. So they have obtained as pi by 9 radians. And since the distance between the pivot center and the roller center is 70 mm, so they have given us the 70 mm as the roller follow center to the roller diameter. That is A1A. So here A is the center, A1A2 is the oscillatory motion. So the distance between A1 and A is taken as 70 mm. Therefore, length of the arc AA2 along with the displacement of the roller actually takes place. So this is the arc which is made by the oscillatory motion, that is from A2 to A. That is A to A2. So it is 70 mm into pi by 9. That is displacement into angular displacement. 70 into pi by 9, that is total 24.5 mm. So we have obtained it as 24.5 mm. So next we have to draw the displacement diagram for the given data. So the stroke is given as, that is obtained as 24.5 mm. So with the height as 24.5 mm and length as, that is from A to the last point, we are taking the 360 degrees and converting it into the centimeter scale, that is 1 centimeter is equal to your own choice, but I am taking here as 1 centimeter is equal to 10 degrees, that is total 360 degrees is divided into 36 centimeters, that is 36 centimeters is equal to 360 degrees. So after after constructing the rectangle, you have to divide the sections into 4 sections. First one is the outstroke, that is outward motion. Second one is the dwell period. Third one is the return stroke, that is the return of the follower to its original one. And last one is the dwell period again. So after dividing the four sections, you have to draw a semicircle here. So taking the center as C dash, draw a semicircle to its length of 24.5 mm and divide the semicircle into 6 equal divisions and name it as A, B, C, D, E. So after dividing the semicircle into 6 equal divisions, then divide the outstroke length, that is 90 degrees. So 90 degrees means 9 centimeters. So divide the 9 centimeters length into 6 equal parts. Six equal parts. And in this displacement diagram, half of this section is in the simple harmonic motion and half of the later half is in the uniform acceleration and deceleration, that is retardation. So in the first motion, that is the outstroke motion, you have to draw the simple harmonic motion. That is why we are taking the semicircle here, drawing the semicircle to represent the simple harmonic motion. So we are going to take the 6 equal parts. In that, take the center, that is the third equal part, and draw the vertical lines from all the divided points. And intersect the vertical lines from the horizontal points, that is the horizontal lines from the divided section of the semicircle. So here we had seen the A, B, C, D, E points, that is small a, B, C, D, E. So from the points, intersect the first point with the first vertical line, second point with the second vertical line through the horizontal lines, and then we have the intersection points as capital B, capital C, D, E, F. So we get the points as B, C, D, E, F between the points A and G. Connect those all points by using the freehand curve. Draw all those points by using the freehand curve. So then second one is the dwell period. So in the dwell period, we does not move the any line. We simply draw the straight line. So draw the straight line from G to H. Next, we have to draw the return stroke, that is the return motion by the uniform acceleration and deceleration motion. So divide the 75 degrees, that is 7 centimeter, 7.5 centimeter into 6 equal parts, and from the center line, that is center vertical line 3 dash. So from the center vertical line 3 dash, you have to divide the 3 dash line also into 6 number of equal parts, that is equal number of parts. Then join the first 3 lines, that is the first 3 points to the H line and later 2 points to the P point. Then join the points as J, K, L, M, N to the intersection points of the two lines. So from the intersection of point through the two lines, we obtain the points as J, K, L, M, N. Then draw the curve with a freehand curve. So the pink color line is the freehand curve here. Then the last remaining period, that is 160 degrees, is the dwell period, which remains in the straight line. Next we have to indicate the angles and the points. That is 90 degrees to the outstroke, 45 degrees to the dwell period, 75 degrees to the return stroke, and 160 degrees to the dwell period. So this is the displacement diagram. So after drawing the displacement diagram, half of the problem has been solved. Next we have to draw the cam profile by using the displacement diagram and the given information. So first of all, draw the cam circle by the given length, that is 50 mm as radius. So after drawing the circle, that is the base circle, we have to draw the prime circle. So that is prime circle of the follower. So that is 60 mm from the center of the cam circle. So from the 60 center of the cam, we are going to draw it as 60 mm. Then divide the cam profile into four parts, that is 90 degrees, 45 degrees, 75 degrees and 160 degrees. So then we have to take the distance from the roller, that is 70 mm, because this is the oscillating roller follower which rotates in this motion. So we have to take the distance from this, that is 70 mm, and start from that point only. So the angle of section starting from that point only, that is 90 degrees. Then divide the section, the remaining sections according to that. So by taking from this point, that is A to O, we have started the point and divide the section into 6 number of equal parts. So from this dotted line, you have to divide the section into 6 equal parts, in which 90 degrees is divided into 6, that is 15 degrees for each section. Then draw the lines to that part and go to the displacement diagram. Take the first, that is the outstroke section. So take the length as 1 to B and draw the cutters from 1 to B here. In a similar section, take 2C, 3D, 4E, 5F and 6G as lengths and draw the arcs from there, cut those arcs from there, that is from A to B. And by these points you have to draw the circles like this, that is Then take the second section as dual period, that is 45 degrees. So there we have nothing to move. Then take the values as A, B, C, D, E, F, and G. Then draw the return stroke section, that is of 75 degrees, and do the same procedure as we have done in the displacement diagram. So by the length, that is 1 dash to J, 2 dash to K, 3 dash to L, 4 dash to M, and 5 dash to N. Take the length as that one and divide from the 1 dash to J, 2 dash to, so that is the section of point. We have to cut it and draw the lines. Then we have obtained the points as H, J, K, L, M, N, and P. These are the points we have obtained from these points. And next, last period is the 12 period remaining 160 degrees. So you have to draw the remaining 160 degrees in the thickish line. So that is the question, and we have to draw the two circles there. First one is the base circle which represents the cam circle there. Second one is the prime circle, which represents the roller to be roll. So we have to draw the roller from that. That is because this is an oscillatory motion. Then we have to take the following procedure. So because the follower moves with the simple harmonic motion during the outstroke and uniform acceleration and retardation during the return stroke. Therefore, the displacement diagram is drawn in the similar way we have discussed. First of all, locate the pivot point A1, which is 70 mm to the left and 60 mm above the axis of the cam. Then, since the distance of the pivot center A and the follower center, that is follower roller center A, is 70 mm, that is they have taken as 70 mm, and the roller diameter is 20 mm. Since the distance between the pivot center A1 from the center A is 70 mm and the roller diameter is 20 mm, therefore draw a circle with center A and radius equal to the radius of the roller, that is 10 mm. So we have to take it as 10 mm for removing it. Then we find that the minimum radius of the cam is 50 mm by taking off the 10 mm radius. Next, we have taken the OA as the minimum radius of the cam and radius of the follower, that is 50 plus 60, 10 mm, that is 60 mm. Then we have to draw the profile of the cam completely. So that is the procedure for drawing the cam. So in the cam profile, we have to take this, that is the diameter of the roller is 50 mm, but we have to take the point of the pivot from the, that is 70 mm. So the distance between covered here is 60 mm in total. We have taken the prime circle. So thereby, after concluding it, we have to draw these sections. So by here, I'm going to conclude this section. So that is the procedure for drawing the oscillating roller follower, which you have seen. So we have to take the oscillating distance. So by taking this distance, we have to fix this point of the roller, and then we have to move it. So that is by taking the section from here. The oscillation has been starting from the point in this section. Thank you.